In this video, we're going to go a little more in depth with generic rectangle. Remember, generic rectangle is a simplified version of the algebra tile diagram. For example, if I have the algebra tile of x squared here, 1x squared tile, 3x tile, 2x tile here, and 6 unit tile here, with a dimension of x, 1, 1, 1, and x, 1, 1 here, this algebra tile can be translated and simplified into what we call a generic rectangle, or you can think of it as just a box, a 2 by 2 box, with this term is being x squared, and how many x's here? Well, there are 3 x's here, and 2 x's on the bottom here, and 6 unit tiles here, 6. So I notice that these two diagonals here, this diagonal with between the 3x and the 2x can be collected into 5x. In other words, I can write as x plus 3 times x plus 2 is x squared plus 5x plus 6. Now notice that the x squared is really the area of this box with the dimension x times x. And the 3x comes from x times 3. The 2x here comes from x times 2, and the 6 comes from 2 times 3. So inside each box is the area of that box, derived from multiplying the length and width of each of this box. So this is important to remember, that the generic rectangle, it really represents the area of each of the sub-box here. Look at using generic rectangle, or I'm going to call it the box method, to multiply 3x times x minus 5. Well, I can draw a 1 by 2 rectangle, the length being 3x, the top is x and minus 5. Again, to try to get the area of this box, I do 3x times x becomes 3x squared, and 3x times negative 5 becomes negative 15x. So the result simply comes out to be 3x squared minus 15x. Okay, so now to use this to factor, we're going to factor this polynomial called 12x cubed plus 15x using a box method or the generic rectangle method. Well, this is an interesting polynomial because it's got two terms. The first term is a cubic term, 12x cubed. The next term is 15x. So my job is to figure out what is the dimension of each of these parts needs to be. And let's take a look. Well, 12x cubed and 15x share this side. And this side is what we call the length of this box. And also in algebra terms, we call this the greatest common factor, the GCF. So what does 12 and 15 have in common? Is their greatest common factor? Well, that's 3. What about between x cubed and x? Well, they have 1x in common. So the common length is 3x. Now, how do we figure out the width? Well, the width is whatever we need to multiply 3x by in order to get 12x cubed. And that's going to be 4x squared here. And for this box, 3x times 5 is going to be 15x. So the factoring result can be written as 3x times their individual width, which is 4x squared plus 5. And this is this is kind of undistribution. If I distribute through, I will see it's 3x times 4x squared, which is 12x cubed, 3x times 5, which is 15x. Now we're going to look at multiplying binomials with the box method. we've done that a few times and just want to clear up with how to exactly do binomial. So for example, if I have 2x minus 5 times x plus 4, we're going to set up a 2 by 2 box, and the dimension of the box is 2x minus 5 and x plus 4. Again, we're going to get the area of each of these boxes by multiplying the length and width. So 2x times the x is 2x squared. X times negative 5 is negative 5x. 4 times 2x is 8x. 4 times negative 5 is negative 20. And again, we can collect the like terms on the diagonal, and that becomes 3x here. So the result becomes 2x squared plus 3x minus 20. And we can show that if I were to multiply this algebraically, I will get 2x times x, which is 2x squared. 2x times 4, which is 8x. And negative 5x, 5 times x is negative 5x. So these blue terms come from the blue multiplication. And lastly, the negative 5 times 4 gives me the negative 20. And so this is how the box method also corresponds with the algebra. Now let's actually we're going to use the box method to figure out some of the missing terms of a generic rectangle and see how we can use our factoring method. Think about factoring. So if I have 2x squared here, 10x, and 5 here, I would like to know what is this missing box, and I will also like to find out the dimension of each of the box. So we're going to approach the top box. Since both of the terms in the top box are given, we're going to approach the top box and the bottom box separately. On the top, between 2x squared and 10x, what is it that they have in common? This red side that they share, what is it they have in common? Or what is their greatest common factor? Well, I know that 2 is the greatest common factor between 2 and 10, and x is the common factor between x squared and x. So if that's 2x for their greatest common factor, then this length must be must be x. Let me erase this. This side must be x in order for it to become 2x squared. And this side must be 5 in order for it to become the 10x here. So 5 and x here. Well, this helps me determine some of the side lengths in the blue box, because this is 5. That means the bottom here is 5, which means this length that right here has to be 1 in order for 5 times 1 to be 5. Well, that becomes easy because now this blue side is going to be 1 for this question mark. And now what do I have left? Well, I have 1 times the x is going to give me x here. So now if I collect the like terms on the diagonal, the 10x and x is going to become 11x. Let's take a look on how we're going to write this whole thing together. We're going to have this dimension, which is 2x plus 1, and the other dimension, which is x plus 5, and the result is going to be 2x squared plus 11x plus 5. And we can check that by doing the algebra. Again, 2x times x is 2x squared, and the 2x times 5 and 1x is going to give me the 10x and x, which gives me 11x. And the 1 times 5 is going to be the 5. So next you're going to do some practice with this generic rectangle and use that to figure out the missing area as well as the dimensions of individual boxes. So the final thing that we want to notice is that for every generic rectangle with binomial multiplication, in the end result of your generic rectangle multiplication, for example, the previous one we were just looking at, we had 2x squared, 10x, x, and 5. If you notice that the diagonals, the two diagonals of this box, they multiply to be exactly the same thing. So 2x squared times 5 is 10x squared, and x times 10x is also 10x squared. And here it's cool to notice that the 10 and the 10 is what they have in common as they multiply together.